This conference will now be recorded.
Right. Can you tell me what is the main role of CDM?
It's a process of collecting and managing data from research.
It's just not only collecting the data, okay? It's just not only collecting data, it will clean the data, isn't it? Clean as well, validate the data. It will clean the data, it will validate the data. So to clean the data, to validate the data, okay, to clean and validate the data, first you have to, I'm just explaining the process in reverse. Final ultimate goal is to clean the data, validate the data. To clean the data, do we need to collect this data into databases? Do we need to collect the data into databases?
Yes.
Enter this data into databases. So to enter the data into databases, do we need to have data entry screens? Where do you enter data? In the data entry screen.
Yes.
So we must have data entry screen in our database, which are electronic CRFs. So you need to design the electronic CRFs. That means before you enter data, you have to make sure that you have data entry screen in your database. Right? So now the question is, do we have these data entry screens common to all the studies or specific to that study?
It is specific to clinical studies.
It is not common, right? So
It
some
is
will
not.
be common, like demographic vitals and all. Some will be common. Okay. But most of the times specific to the particular study. So that means before you start designing the screen, you must have the study. It will definitely ask you, your system will ask you, you are creating the data entry screens, to which study that you are creating data entry screen. Okay, it will ask you to select the screen.
I have one question. CDM have to design the CRF. So
Yes,
we should. Okay. So
yes,
CRF will come sponsored, right? So then only we should design the
correct.
CRF.
Hmm.
Oh, okay. So main document from sponsor and then design should be in the CDM, the process.
Hmm. Correct.
Okay.
Okay. Then design the study. Right. That means the first step is the basic step is study design. Study design is nothing but protocol design. Okay. So CDM life cycle. We have three phases of the CDM life cycle. We have three phases of the CDM life cycle. So one is
Design.
study, startup. Study, startup or setup. Study, conduct. Study, close out. So these are the main steps of the CDM life cycle. Phases, nothing. Study, close out. Startup, conduct, close out. Okay. So startup, we have few steps, 5 steps. In that, the first step is study design. The second step is CRF design, electronic CRF design. Third one, validation checks, procedures. Fourth one, derivation checks, procedures. Validation, derivation. Fifth one, UAT, user acceptance testing. UAT, user acceptance testing. Okay, user acceptance testing. What is study design? As you know, the first step is study design, which is important because further you perform any step, it will definitely ask you to select because we will not work on only one study. We'll work on multiple studies. System will ask you which study that you're working with, which study that you're creating the CRFs, validations, derivations, and all. Okay, so study design, we have different steps here. Naming and defining the study. What does it mean? We need to add the protocol title, protocol number, in which country that we are conducting these studies. All these that we have to define. Now, number of days, how many number of days that you're going to conduct the study. Who is the company, like which is the company organizing this? All these details that we add in naming and defining the study. In the second step, we create intervals and events. What are the intervals? Intervals are nothing but study time intervals, phases, screening, baseline, treatment, follow-up. Those are all intervals. What are the events then? Events are visits called CPE, clinical plan event. investigator. So we'll create intervals and events. We'll create the sites. What are the sites? These are the places where we conduct the studies. We'll assign these sites to study. Creating investigator. So creating investigator, assigning investigator to site, because each and every site must have responsible investigator. Then creating patient positions, assigning patient positions to the site. These are all the steps in the study design. Then what is CRF design? This is nothing but designing data entry screen. The CRF design will start the basic data point with questions. We'll create the questions. We'll assign the questions to question groups. We'll assign questions to question groups. Okay. So DCM, DCI, DCI book, DCM, DCI, DCI book. So what is this DCM? It is data collection module. Data collection module. Data collection instrument. Data collection module, data collection instrument. So DCM is
Data collection
module. DCI is data collection instrument.
module.
So all the group of DCIs, all the group of question groups, logically related question groups grouped under DCM. Logically related DCMs grouped under DCI. Logically related DCIs grouped under DCI book. Okay. The questions, question groups, DCM, DCI, DCI book. So these are all levels of the CRF design. So can you recall once the CRF design content, level of CRF design?
Yeah, ECRF design
Mhm.
and validation
Okay.
and the yeah, user acceptance test like EAT.
Mm. Okay. Within the CRF design, what are all the steps?
Within the CRF, DCM, DCI, question and question groups, and DCI book.
Mm. Right. Questions, question groups, DCM, DCI, DCI book. Correct. Validation checks are to check the validity of the data. These processes to check the validity of the data. This is to derive the values. This is to derive the data. Derivation checks to derive the data. UAT, user acceptance testing. So before we go to live mode, we have to test all of them. So let us discuss with the validation checks. First, who will create the validation checks? Usually, CDM means clinical data managers will not create the validations. Clinical data managers will not create the validation processes. Who will create then? Edit check program. Programmer. So edit check programmers will create, or database programmers. Edit check programmers are database programmers. Then they are typically IT guys. They are typically IT people. They will prepare, but they don't know what to prepare. They don't know what kind of procedures that you require. So that input will be given by the CDM, clinical data managers. That means what to create, what exactly the study required, the input that you get from the CDM, clinical data managers. Okay. So these are called specifications. These are called specifications. So what are the specifications? Whatever the data manager give, those are called edit check specifications. Edit check specifications. Specs. The specifications will be given to the database programmers. Database programmers will create the processes based upon the specifications given by the data managers. So who will give the specifications? Clinical data managers will provide specifications to the edit check programmers. Based on that, they will create the edit check. Let me just give you simple example for this. Specification. This is a specification. That means your requirement, nothing but. This is your requirement. Requirement one. Um, so your study is on pregnant women.
Hello.
Yeah. So specification one, you are conducting on pregnant women. Your studies on pregnant women. That means your gender should be female. Gender should be female. That is your requirement. Should not be male, should not be any other gender. Should be female. So this is your requirement specification. How to create the edit check? Edit check is nothing but logical condition, expression. Edit check is nothing but condition or expression. Let's say gender not equals to female. So this is a condition. Not equals to, we can also write like this, not equals to. This is not symbol, or this is also not symbol, not equals to female. So this is a condition. If this condition is true, satisfied, if this condition is true or satisfied, if this condition is true, then system will create the discrepancy, error. Okay. So if not equals, if this condition is true, when will this condition is true? Whenever you enter gender, any other than female. That means whenever gender is not female, not equals to female, then your system will show you error. Clear it?
Yes.
Specification 2. I don't want to recruit the people age should not be less than age should not be less than 18. Should not be less than 18. Can you tell me edit check for this?
Age not equal to 18.
When I enter age not equals to 18. That means whenever age is not 18, it will show you error, right? That means if you
Yes.
enter 17, 16, 15, or if you enter 21, 22, 23, 25, 57, if you enter any number which is not 18, it will show you error. But that is not your requirement, right? Your
Yes.
requirement is whenever
Okay.
the age is less than 18,
Yeah.
then only your system has to show the error. If you want the system to show you error like that, how to write the condition?
Less than 18. We can write less than 18.
Hmm. Less than 18 is good.
Yes.
Okay. So whenever you enter less than 18, it will show you error. Let's say another specification: systolic, diastolic. Systolic blood pressure, diastolic blood pressure. So what are the systolic and diastolic? Let's say diastolic blood pressure always should be, yeah, this is your condition. Diastolic should not be greater than systolic. How do we write that in Czech?
Like, DPP greater than, like greater symbol than SPT.
DBP good. Greater SPP. Right. If this condition is true, whenever you enter more diastolic than systolic, some will show you error.
Error.
Like this, we create the validation. So what are the derivations? The derivation is to derive and convert the values. Not only derive, convert the values also. Okay. So like this. Let's say age. Can we derive the age from the date of birth? Let's say if the date of birth is 12/04/1987. 1987. What will be the age? 35 years, right?
Yes.
So how did we derive this? Current date minus date of birth.
Date of birth.
So you can easily get the age. Age, and we have let's see, if you want to find the duration, start date, stop date minus start date. Okay, let's see, to convert the values also. Weight is given in kgs. It will convert it into lb. Okay, height is given in centimeters. It is converted into
Inches. It's okay.
inches, otherwise whichever. Like this, conversions, derivations, all these we use derivation procedures. And whatever we created here, whatever we created till now, CRFs, study, validations, derivations, we all test them in test mode. Okay, so we test them in the test mode. So we test them in the test mode. And we'll move them to production mode. We'll move them to production. Production means live mode. We'll test them in the test mode with dummy data. We'll test them in the test mode with the dummy data, move them to production mode.
Dummy data means they compare the data.
No, just dummy, random data, x1, x2, x3, like that. We'll test.
Okay.
While testing, we'll use the dummy data. We cannot test with the live data, right? That's the reason.
Yes.
Test them in test mode with the dummy data. Once they are perfect, then we'll move to production mode. Okay. In the study conduct, these are all set up. We'll just make everything ready for the data entry and cleaning the data. So data entry and cleaning the data we do here. Actually, data entry not comes under conduct. Before conduct only, you have to make sure the data is entered into databases. What is data entry? Entering the data into databases. We have first pass entry. The same data will be entered by the second person. That is second pass entry. The first pass, second pass, and so we have first pass, we have second pass, and comparison, reconciliation. We have comparison, reconciliation. Means the same data is entered into two different screens. First pass screen, second pass screen. We need to compare both the screens to check whether data is entered correct, valid, accurate, complete between the first pass and second pass entry screens. This is not the discrepancy management because we are just only comparing first pass, second pass entries. That's all. We are not identifying the errors here. We'll only make sure whether the data that is entered into first pass screen, whether it is correct and correctly entered or not, whether it is compared with the second pass. That's all.
So
The
they
quality
entered in two databases.
two data entry screens, not two
Okay,
databases. Yeah, on entry screens by two different persons. Let's say you are the first pass person, you are entering data. I'm the second pass person, I'm entering the data.
Okay.
Clear, right? The first pass, second pass, then we have comparison, reconciliation. Comparison reconciliation will only compare the first pass and second pass entry. If you have any difference between these two entry screens, that will be identified. Second one, once you enter the data into database, we'll do data validation. So what is data validation here?
To validate first pass and second pass entry.
Whatever the data that is entered. Okay,
Yes.
let us assume there is no second pass entry. Second pass always not mandatory. If it is electronic collection, second pass is not even required. If it is paper-based collection, then only second pass is required. Okay. To avoid the data entry errors, we'll go for the second pass. While entering data, so most of the people will do mistakes, right? To confirm that, they'll go for the second pass. Okay. So data validation is the thing but to Check the validity of the data. To check the validity, accuracy, consistency of the data. What we do here, we run the validation processes. See, whatever we created here, you can see here. Whatever we created here, derivations, validations, all these we run here. All at a time that you want to run, it is called batch validation. What do you mean by batch validation? Entering, executing all the procedures at a time in a single shot. That is batch validation. Let's say last 2 days I'm entering data for 30 patients. For your study, you have around 20 validation procedures. Last 2 days I entered 30 patient data. For our study total, I have 20 validation checks. Okay, so when you run batch validation, all 20 procedures will be executed over 30 patients' data. Then it will show you discrepancies. So some discrepancies, some checks are run during the data entry itself. But some checks, those are run after completion of the data entry, like this batch validation. We'll plan after completion of data entry, we'll plan for the batch validation. So some checks are run at the time that you are entering data into databases. So we'll get the discrepancy. We will call it as discrepancy management. Discrepancy management. What is discrepancy management? It is also called query resolution. What is discrepancy management? We'll identify the discrepancy. We'll see later. Discrepancy management is important. Validation also important. I'll explain that. So we'll manage all the discrepancies. Okay, so data coding will be done here. You know the coding, right?
Yes.
SAE reconciliation also done here. You know SAE reconciliation.
Yes.
And lab data reconciliation also done here. Lab data reconciliation or external data reconciliation. Hello, sir. Lab data reconciliation, external data reconciliation. It is also called vendor data reconciliation. Can you tell me what is data coding?
Converting verbatim term to standard terms, standard medical terms.
Using dictionaries, right?
Using dictionaries, yes. Standard
What is SAE reconciliation then?
SAE means serious adverse event.
Mhm.
Reconciliation means like a comparison key, like between safety variables, between two databases, like safety drug safety database and clinical database.
Correct, correct. Similarly, we have lab data reconciliation also. So whatever the data that is collected in lab interfaces will compare with the CDM database. You will compare with CDM data. Whatever the data that is entered into system, okay. So lab databases and the CDM databases same like assay reconciliation. In assay reconciliation, we compare safety data, but here we compare lab data between lab interfaces and lab database, and a clinical database, CDM database. Okay. So once we do all these, we'll close the study. So closing means locking and freezing. What we do in the closeout, what we do, we have the pre-closure checks. We have pre-closure checks. That means we have to check for all these whether coding is done properly. So whether say reconciliation is done properly, whether lab data is reconciliation done properly. They'll check for the quality. They check for the data, whether data is entered or not, whether data is completely entered or not. Then we'll lock, then we'll freeze. Okay, so these are all startup conduct closeout. In the startup, it will take 15% of the work, that's all. Though we have lot of steps here, but this is not repetitive process. We are just setting up everything. Once you set up everything, you will not touch it again. But this is repetitive. As you go on collecting the data, go on entering data, go on validating data, this will take remaining 25% of the work. Right? Let's see how the data validation done. What is data validation?
Validate the data from whatever the data we have to validate from the
Right.
database.
Correct. I'll open the slide. The data validation is nothing but procedures to check the accuracy, completeness of the data, consistency of the data. So this is very important to understand validation and types of discrepancies. Okay. To ensure the data accuracy and consistency, completeness. So these can be automated or manual processes to detect missing, logical, any data that conflict with the protocol requirements. Discrepancy is nothing but it does not necessarily indicate an error. It does not necessarily indicate an error. It can be anything which is not as per your expectations. That means what you have in the database is one thing. It's not matching with the requirement, protocol requirement. Okay, right? So we have four steps basically in the validation procedures. Planning. Planning means sponsor phase will decide what all the checks should be used, which code list is appropriate, what procedures will be used for invalid results, and the checks, code lists, procedures, these are all should be documented. So give me one moment, Nandini. I'll just start in 2 minutes, okay?
Yeah, sure.
Right. So in the validation, we have 4 steps. Okay, so the first step is planning. Okay, in the planning, first we'll plan what are all the checks required, what are all the codelets required to detect the invalid results. The planning all should be documented in DVP. We'll have DVP data validation plan. Okay, so how to validate data, what are all the checks required, procedures required, which code list is appropriate for questions. So those are all will be documented in DVP data validation plan. Okay, so implementation and testing, the checks, code list are implemented in the clinical database. So whatever that we have planned, all will be implemented in the database. So once we implement, we have to test them and we'll make it ready to use in the live environment. So once they're ready in the live environment, we can start data entry. So some checks are run during the data entry, some checks are run after completion of data entry at the intervals. So invalid results will be fixed, allowed using planned procedures. So then we'll log the data. When no more updates, no more changes to the data are expected, database will be locked. Okay, so data validation, edit checks. In the clinical trial, the critical task is to ensure that the data collected, data entered into system, database is valid, correct, logically sound. So the critical task is to ensure the data collected, data entered into system, to make sure it is valid, accurate, complete, logically sound. So this required, we need to have good protocol, good CRFs, good procedures, good validation procedures, good review procedures, and good complete set of data like CRF, guidelines, entry guidelines, completion guidelines, which is called CCG, CRF completion guidelines. Okay. Clarification process, source data verification, review process. So edit checks are the programming instructions which test validity of the data. Let us understand the edit check, but before, so we go to edit checks, let us understand the discrepancy. So what is discrepancy? It can be invalid, incomplete, illogical, inconsistent, inaccurate data. Simple terminology, anything which is not as per your requirement. It is called discrepancy. So we have 2 types of discrepancy. In fact, not 2 types, 4 types of discrepancy. Univariate, multivariate, manual, indicator. Univariate, manual, indicator. Okay, univariate, multivariate, manual, indicator. Let us see univariate. Let us understand when will we get this, how will we get this, and what is univariate. So what is univariate? Whenever discrepancy belongs to one field. Whenever discrepancy belongs to one field, it is called univariate discrepancy. One field or one variable or one response, it is called univariate discrepancy. So generally, if you can recall the CRF design, CRF design will be done in 5-level hierarchy: questions, question groups, DCM, DCI, DCI book. Okay. So when we are creating questions, what we do, we'll assign some attributes to the questions like this. See, question name. First we write the question name, then we write the data type, then we write the date format, we write the time formats, and length, range, data type, date format, time format, length, lower bound, upper bound, is it mandatory, code list. Code list is nothing but list of values. Let's say we are creating age here. Let us assume in the database you are creating the question age, assigning all the data types. Age is numeric, it's not the date, it's not the time, it's not the length. I'm just giving only 5 here. Lower bound 25, upper bound 75, lower 25, upper 75. So we have the code list. We don't have the code list because age is open-ended. Is it mandatory to collect? No. So this is a age question created. Let's say I have the data entry screen. I'm just start entering the data. I entered age 23 years. So will this show you discrepancy?
No.
So are we following all the attributes or are we deviating from the attributes? Are we following all the attributes, whatever I assigned? Or am I deviating anywhere while entering 23 years?
No.
I think I see.
You can see here, Data type numeric, right?
Yeah.
But I entered character here. 23 years also that I'm entering. So as the question is defined as numeric, but the value that you entered is alphanumeric. This is mismatch. Mismatch with the attributes, what we defined. It's not correct one, correct value. It will show you discrepancy, that is univariate discrepancy, because only one field, right? Age is one field. Now, length we defined as 5. We are exceeding the length, right? 23 years. Exceeding the length of 5. Total 8 we entered here, which is wrong. So lower I defined as 25, but entering the value below 25. The range mismatch. Mismatching with the range of values. Okay. So this is univariate discrepancy. Univariate discrepancies are time of entry edit checks. What do you mean by time of entry edit checks? At the time that you are entering data, these checks will be executed. System will run automatically the univariate edit checks to identify the univariate discrepancies. These are called time of entry edit checks. At the time that you are entering data, if anything wrong, anything not as per attribute, system will immediately show you create error. Okay, so let's say date of birth. We have date of birth, data type is date, DDMMYY format, no time format, length 10, no upper, no lower, it is open, no code list, mandatory. Let's say I enter date of birth 16/04/1987. Is there anything wrong in the date that I entered, or everything perfect?
Everything good.
Okay, let's say when I enter like this, then
That's
It's not
incorrect.
now we have, right? Now we have the discrepancy because the date that we configured DDMMYY, but the data that you are entering is in MMDDYY. Month first, then date. Okay, so let's say gender, character, no date format, no time format, length 8 that I'm going to give, no lower, no upper. I have the code list male, female, mandatory, yes. Let's say when I'm entering gender, I select unknown. Will this show you discrepancy?
Yes, it will.
Yes. Yes.
So code list that we have male, female, I have to choose from the code list only when I have code list. When I enter my own value, definitely system will show you discrepancy. Clear it? So this is univariate. So univariate belongs to one field. When will we get this? At the time that you are entering data, system will cross-check with the attributes. If there is mismatch with the attribute, system will create univariate. So we have attributes defined. If you are deviating from the attribute, then your system will create univariate. What are multivariate then? Multivariate are the back-end edit checks, not at the time of. For multivariate, you need to follow the 4 steps. You need to plan to create the edit checks, conditional checks. Then we'll test them. Move to production. So we need to have edit checks created to detect the multivariate. Let's say, so this is your requirement. Diastolic should not be greater than systolic beat. The edit check will be diastolic greater than systolic. Means when this condition true, whenever this condition is satisfied, whenever this condition is satisfied, system will show you error. So when will the system show you error? Backend after completion of data entry, not at the time that you are entering data entry. So after completion of data entry, we'll plan to run these edit checks, whatever we created. Then your system will show you discrepancies. Okay. So whenever you want to check for the multivariate, you need to run the validation checks, batch validation. Batch validation is nothing but executing all the procedures at a time. The univariate will be detected at the time of data entry, but multivariate after completion of data entry, whatever the procedures planned, we must run them against the data that you already entered. These are multivariate edit checks. Okay, now you can see this. Edit checks are the programming instructions which test validity of the input in data. Edit checks, auditable process, usually automated, assessing the data content against format, logical, range, other properties which are intended to reduce the error. Okay, so time of entry, backend edit checks, you know. So edit checks allow us to use the power of computer to check for the illogical, incomplete, inconsistent data. 2 types of edit checks. Univariate edit checks are to detect univariate discrepancies. Multivariate edit checks are to detect multivariate discrepancies. Aggregate edit checks. You can just look at this one. this is what just now we discussed with examples. Let us see discrepancy management. In this, we are going to address other two discrepancies also: univariate, multivariate, manual, indicator. So discrepancy may be due to inconsistent data, missing range, deviations from the protocol. It can be generated by the data entry error. Discrepancy can be generated by data entry error. Sometimes investigator may be incorrectly reporting the value, incorrect attribute on a question, just now we discussed. It can be range or data type. So sometimes the CRF terminology not quoted in the dictionary. And procedure edit check that finds logical error. Start date later than stop date. Diastolic greater than systolic, like that. Comparing two fields here, that is multivariate. And the last one, manual discrepancy. Entry operator comment, data entry operator comment. Discrepancy, manual discrepancy, nothing but data entry operator comment. Sometimes operator comment is created, that is called manual discrepancy. So it is called query resolution. Discrepancy management include review the discrepancy, identifying the reason, resolving it with the documentary proof. We need to resolve it with documentary proof, or we need to declare it as irresolvable. Okay, so we have basically three steps: review the discrepancy, investigate the reason, and the documentary proof, resolving it with the documentary proof. Or in case if you are unable to resolve, we can declare it as irresolvable. So discrepancy management helps in cleaning the data, gathers enough evidence for the deviations, observed in the data. And discrepancy is a variance between the actual response and the expected response. So discrepancy is a variance between actual response and the expected response. It does not necessarily indicate an error, but the data which does not meet the expectations. So discrepancies are resolved according to protocol, according to the guidelines. Okay, so these are all the steps: identifying reason, then resolve it. You know univariate and multivariate. Let us understand the indicator discrepancy. So let's say you have the question, do you smoke? You have question, do you smoke? The answers will be yes or no. Do you smoke? Answers will be yes or no. So if S is selected, the follow-up question must be filled out. How often? Follow-up question must be filled. How often? How often must be filled? When do you smoke is selected? Yes. It must not be filled. When do you smoke? Answer selected? No. So if indicator question is yes, follow-up question must be filled. If indicator question is no, follow-up must not fill. But when will we get the indicator discrepancy? When follow-up question is either collected, when it should not be, or not collected, when it should be. Okay. So when you fill how often, answer is selected no. When you're not filling how often, if answer is selected yes, indicator discrepancy will be created. This is univariate when data point does not fall within the predetermined parameters for that particular response. So as defined in the question attributes. See the examples. DVG is the code list. Mandatory in case of the question is selected mandatory, but no response is entered. Okay, field length if you exceed the length. Multivariate generally during batch validation when data points are compared within the visits across the visits, within the CRF across the CRF. Whatever like does not meet the criteria, whatever we defined in the database. Okay. And these are the manual discrepancies. Manual discrepancies are not generated by the system, not resolved by the system. User will create them. User will resolve them. So manual discrepancies are the checks which cannot be programmed, which cannot be generated by the system. So these discrepancies are addressed through the operator comments. And manual discrepancies are created with the operator. Most of the times manual discrepancy is addressed with the operator comment, data entry operator comment. Okay. These are identified through the operator comment, addressed through operator comment. Let's say when the data entry person entering the data, if they are unable to understand some value or some abbreviation is there, they're not able to get it. They're not able to enter the data. Illegible text. Text is not legible. Symbols used. Okay. So when they are entering data, if they find anything like that, they can add a note to the field. Database will provide you that feature. You can add your voice, you can add note to the particular field. So that so they will just attach a note to the field. Your system will provide a feature. System will allow you to write the comment to the particular field. This comment is called manual discrepancies. This will be reviewed by the data managers or validators. Operator comment allow us to communicate between data entry operator and data validator, means data manager. So when the data entry person facing some problem, they cannot all the way call the data managers and inform their problem. They can simply add a note. That note will be reviewed by the managers or validators. They'll resolve it. These are the status, review status. So whenever discrepancy is created, the default status, it will be unreviewed. So whenever new discrepancy is created, default status applied is unreviewed. Who will apply this status? System will apply the status. So whenever new discrepancy is created, it will be unreviewed. When it is unreviewed, investigator will review that. CDM people will review that. They will create data clarification forms, DCF, query forms, nothing but. Send it to site. That is called investigator review. So whenever you see the discrepancy, you are reviewing that, you are creating a query form, sending it to investigator. Investigator review. Passive review is nothing but you're waiting for something to be resolved. Passive review means you're waiting for one more discrepancy to be resolved. See, discrepancy that depends upon resolution of some other discrepancy for which you already sent a DCF. On hold, waiting for more information. Irresolvable, from investigator, no information. So when it is resolved, irresolvable. In both the cases, system will apply the status closed. If you resolve the issue or if you are stating it as irresolvable, in both the cases, system will apply closed. Next, audit. So whenever you update anything, any value in the system, it will ask you to enter the reason for the update. What kind of update that you did and reason for it. Okay, so whenever you enter the data into system will pop up. Whenever you want to edit the data in the system, electronic data, system will pop up asking you to enter the reason, what kind of modification, who is modifying that, date and time of modification. This all will be captured in the audit trail. Audit trail is a document which will collect. Audit trail is a document so which is collect all the change information in case if you change anything. Okay, after discrepancy management, we go for lock and freeze. So what is locking? Closing, nothing but closing the data. In the locking, what will we do? Will remove the edit access from the entire team. Okay, so to prevent unauthorized changes. Why do we need to lock the data? To prevent unauthorized changes to the data. Once you validate the data, if someone access and someone change, Again, you need to review the data. That's the reason after validation, when no more updates, we can simply lock and freeze. First lock, then freeze. So this is why we have two types of lock: soft lock, hard lock. In soft locks, what we do, we will remove the edit rights. We'll completely remove the edit rights from entire CDM team, but except Project Data Manager, PDM, except the Project Data Manager. Hard lock. Your edit rights are removed from the entire team, including project leader, including project leader. Including project data manager. Okay. So after soft lock, project manager will still have access. They can edit the data, add the new data, delete the data. So once you soft lock, you cannot unlock. In fact, no need to unlock because project leader will still have access to the data, right? No need to unlock. Without unlocking also, we can update the data, add the data, but via privileged update. Only privileged update will do this. No need to unlock. Unlock, like locking is soft lock. General terminology, it is called locking. Also called temporary locking. Okay. So once we lock, then we go for freeze. Hard lock, edit rights are removed from the entire team, including project leader. Okay. So we cannot edit the data. We cannot delete. We cannot edit. We cannot delete, and we cannot add the new data. Anyway, we cannot add the new data, but you need to unfreeze. Unfreeze if you want to make any changes. Okay. Unfreezes, like freezing is called permanent lock. Hard lock is called freezing. It is called permanent lock. Soft lock is temporary. Edit rights are removed from the team except leader. But hard lock, edit rights are removed from the entire team, Even project leader also will not have access. After freezing, we cannot add the new data, we cannot delete the data, we cannot edit the data. But if you want to do this, you need to unfreeze the data. So when you're locking, you can lock individual CRFs, means DCIs, DCMs also we can lock. DCM, DCI, part of the CRF design. We can even log by site, by investigator, and by patient positions. You can log by investigator, you can log by patient position, you can log by sites. Okay, but you cannot log entire study. You cannot do entire study. But here we can log by the sites, means freeze, we can call hard lock, nothing but. We can freeze by the sites, investigators, patient positions. We can, so we can freeze the entire study. You cannot freeze individual DCIs and DCMs. Okay, so these are all the differences. Soft lock, hard lock. Soft lock, temporary lock, hard lock is permanent lock. First we do soft lock, then we do hard lock. Once you lock, you cannot unlock. But once you freeze, you can unfreeze, because once you lock, no need to unlock. Project leader will still have access within the CDM. But freezing, even project leader also will not have access. That's the reason you have to unfreeze it to edit any data, modify any data. So database closure, it's one of the major steps in the CDM process, which will ensure that the data is clean, ready for the analysis. Okay, so locking database means data has been cleaned, validated, no more modifications allowed for the data. So that the point at which all the clinical trial data has been reviewed, all the queries are resolved, all the issues addressed, the database can no longer be changed in any manner. We go for lock. Locked database is ready to undergo analysis. So locking is to prevent unauthorized changes once the final analysis reporting have begun. It is of two types, soft lock, hard lock. Hard lock referred to final locking of the data after entire validation, whole validation cleaning being completed. Freeze has similar meaning as hard lock. Some companies we use freezing the terminology. So soft lock is generally referred to temporary lock. So in soft lock, edit rights are taken from the entire team. Only project leader will have access to add, modify, delete the data in it. In hard lock, edit rights are taken from the entire team, including project leader. So clinical data management software will have that provision that it will not allow anyone to edit any data. If someone wants to edit data, they have to go for unfreeze. Unfreeze is nothing but, here it is showing unlock, means unlocking the hard lock, which is nothing but unfreezing. That will be captured in the audit trail. Okay, soft lock is performed after database audit findings, which are needed to be corrected before we go for final lock. So before we go for final lock, we'll do the audit and we'll correct all the audit findings. So why do we need to do the soft lock before we do hard lock? Hard lock is important. Can't we directly go for hard lock? Why do we need to go for soft lock? It is just to confirm. Soft lock is to just confirm that you will not find single query. No single query will be found after final lock. Because after freezing, companies will not prefer to unfreeze. Unlocking the database means unfreezing the database, unlocking the hard lock. Because in the soft lock, there is no question of unlock. We will not unlock. There is no option to unlock. Because the CDM team will still have access. Only few people will be remote access. Minimum standards. Ensure that there is a procedure defining the closure. Document completion of all the defined tasks, criteria before the closure. Ensure that all the team members are notified. All the team members are notified, stating that edit access is removed, documented at the final lock. We should have clear procedures to unlock. These are all pre-closure checks. All the data have been received, processed. All the queries are resolved, tracked. Electronic data is in-house, complete, reconciled with the main study database. Means we need to cross-check with the lab data reconciliation. We need to check for all the data, all the queries, lab data reconciliation, and SAE data reconciliation. Coding list, whether this has been reviewed for completeness and consistency. Okay, so coding, SAE reconciliation, lab data reconciliation, queries, data. Those are all will be checked before we close the data. These are all the differences you see. We almost discussed all the points except the cascade effect. So when you freeze one unit, all its internal units will be locked. There is no cascade effect in locking, but there is a cascade effect in freezing. Cascade means once you freeze one unit, internal units also will be locked. No cascade effect in the locking. possible to undo. Freezing, you can unfreeze, but locking, you cannot. Data modifiable also, no, but you can unfreeze the data, then modify the locked data via privileged update, only project leaders or any other equivalent persons. So locking data modifiable, yes, because the project leader will still have access, no need to unlock for that. Effect on future data collection. Prevent future data collection, but locking, no future data collection, no effect on the future data collection. Unit affected, when you're freezing, you can freeze the entire study. You can freeze all these subunits like site, investigator, patient positions. Okay. But locking, you cannot lock the whole study. You can lock all by site, investigator, based on the dates, based on the patients, ranges, DCA, like visits. You can do all these. If you want, you can even lock individual DCAs and DCMs, CRFs. So this is what your differences between lock and freeze. In the practical sessions, again, we'll address all these. Okay, practically how to lock, how to freeze. Even this univariate, multivariate, manual indicator, we are going to address again all these with the database. Okay.
So when the practical going to be start from next week?
Yeah, next week. This week, yeah, Monday.
From Monday. Okay. Thank you.
You're welcome. You can be online.